This topic will introduce radians. Radians are an alternative to degrees for measuring angles. We're going to start with a circle of radius r and consider what would happen if we measured that length r around the circumference of the circle. So in other words, the arc length here is also the radius of the circle. We can complete the sector, and the angle that we get at the centre is defined as 1 radian. The symbol for radian is a small letter c. The c stands for circular measure. We want to consider how many radians would fit into a full turn, or how many of these radii could we fit around the circumference. By inspection, we can see this seems to be a little over 6. We're going to calculate this more accurately. We know that the circumference of a circle is 2 pi r. So if we divide the circumference by the radius, this will tell us how many of those radii will fit around the edge. So 2 pi r divided by r cancels down to 2 pi. This tells us that the number of radians in a full circle or a full turn must be 2 pi. This fits in with what we've observed. We know that pi is about 3.14, so we know that 2 pi is about 6.28. And we saw that a little over 6 of these sectors would fit in the circle. We're going to look for a convenient way of converting between radians and degrees. We can always start with the fact that we know there are 2 pi radians in a full turn, and we also know there are 360 degrees in a full turn. So multiplying or dividing both sides by the same value will always give us equivalent values in radians or degrees. For example, dividing by 2 gives us that pi radians is equivalent to 180 degrees. We can start with the value in radians, multiply by 180 and divide by pi to give us the value in degrees. We can also do the reverse, from degrees to radians, dividing by 180 and multiplying by pi. There is also a way of doing this on the calculator, on the Casio ClassWiz, which we will look at in a minute. You may want to pause the video here and consider how you might calculate 65 degrees in radians. So using the ClassWiz, this can be achieved by first of all making sure that your calculator is in radians mode. You should have a little R at the top of the screen. You can get into radians mode by pressing Shift and then Setup, and then choosing Angle Unit. You're then given 3 options: degree, radian and gradian. We don't use gradian in the A-level course. If you change into radians, there should now be an R at the top of the screen. If you now type 65, you're now going to need a degrees symbol. The degrees symbol comes from pressing Option and choosing Angle Unit. If you choose the degrees symbol, which is 1, you should now have 65 degrees on your screen. And because you're in radians mode, when you press equals, this will convert it into radians. It's come up as 13 over 36 pi, that's exact form. If you press the SD button, it will give you the decimal equivalent, which should be 1.13 radians. Pause now and try the same, but with 232 degrees. This should have come up as 4.05 radians. We can also do the same to get from a value in radians to a value in degrees. For example, 2.4 radians. Because we're trying to convert to degrees, we now need to get our calculator into degrees mode. So again, do this by pressing Shift, Setup, choosing Angle Unit, and this time choosing degree. You should now have a capital D at the top of the screen. You now type 2.4. And we need to get a radians symbol, so we're going to do that by pressing Option, Angle Unit, and then choosing 2, which is an R for radians. You should now have 2.4 radians written on your screen, and when you press equals, it will come up to the nearest degree, 138 degrees. It's actually 137.50987. Try this with 0.1 radians. So this should have come up as about 5.73 degrees. Now pause the slide and consider what each of these values in degrees would be in radians. These are all exact values that we can calculate as fractions of pi. If you're unsure of how to get there, start with 360 degrees being 2 pi radians, and then divide or multiply by various values until you get to the number you need. For example, dividing 360 by 4 gives you 90 degrees, so dividing 2 pi by 4 gives you pi over 2. So for example, we can see that 30 degrees is pi over 6. Similarly, we can see that 45 degrees will be pi over 4. 60 degrees is pi over 3. We can see that this is just double of 30 degrees. 120 degrees is 2 pi over 3. Again, this is just the double of 60 degrees. 180 degrees is pi radians. And 270 degrees, we could achieve this by getting 180 degrees plus 90 degrees, adding pi to pi over 2, we get 3 pi over 2 radians. So sometimes you will get questions where you're asked to leave your answers in exact form. This means that you will write it as a fraction of pi. We're now going to consider how to calculate the length of an arc of a sector and also the area of a sector of a circle. The formulas for these work out very nicely if you are in radians mode. So the angles here are going to always be measured in radians. We also have the radius of the circle. If we want to find the arc length, the formula for it is r times theta, so the radius of the circle multiplied by the angle. The reason for this is that if we start with the circumference of a circle, which is 2 pi r, we can then multiply by the fraction of the circle that we have, which is theta radians out of 2 pi radians altogether. And we can see that the 2 pi here cancels with 2 pi here, leaving us just with r times theta. Similarly, for the area of the sector, we have this formula. We can arrive at this formula by saying we know the area of a full circle is pi r squared, and the fraction of the circle that we have is theta radians out of 2 pi. And we can see here that the pi from here cancels with the pi here, leaving us with r squared multiplied by theta over 2, which can be written as a half r squared theta. So because we have used the fact that the full turn is 2 pi radians, these formulas only work if theta is given in radians. You can convert it, if you're given theta in degrees, you can always convert to radians first before you use these formulas. For this sector here, with a radius of 7 centimetres and an angle of 0.8 radians, calculate the area and calculate the perimeter. The perimeter will be found by calculating the arc length and then adding on 2 lengths of the radius. So first here we can see this length here will also be 7 centimetres, and here we have 0.8 multiplied by 7. This is just r theta, which is 5.6. We can calculate the perimeter therefore as being 7 plus 7 plus 5.6. The sector area is calculated by finding a half r squared theta, which is a half times 7 squared times 0.8. This is 19.6 centimetres squared. For the next sector, again, just pause the slide and calculate the area and the perimeter of the sector. So this time we know we have 36 meters here, and we know that this is r theta, which will be 36 multiplied by pi by 3. We can use the formulas for the perimeter. Then we get 36 plus 36 plus 36 times pi over 3, which gives us approximately 110 meters when rounded. And the sector area, using a half r squared theta, gives us 679 meters squared. Finally, for the third sector, again, pause the slide and calculate the area and the perimeter. So here we know we have 120 degrees. 120 degrees needs to be converted into radians before we use the formulas. So remembering that we know 2 pi radians is 360 degrees, so dividing by 3 gives us 120 degrees, and 120 degrees is 2 pi over 3 radians. You could also have used the calculator function that we mentioned earlier to calculate this. So following this through gives us a perimeter of 23.5 meters and a sector area of 34.4 meters squared. Again, pause the slide and calculate the area and the perimeter of this compound shape. Remember to calculate any missing angles that you might need, and also to make sure your angles are in radians. So first of all, we're just going to calculate a few extra values. For example, we know that 150 degrees can be converted into 5 pi by 6 radians. We can also see we have 150 degrees, we have 90 degrees here and 90 degrees here, leaving us with 30 degrees here. And we know 30 degrees can be converted into pi by 6 radians. We also use the fact that we have a rectangle, so we have a length of 10 here. Because this is a radius of a circle, we also have 10 here, and therefore we also have 10 here. We can now calculate some missing values. So for example, we also know we have 20 here and 20 here. This is because we have a rectangle. So this length 20 is equivalent to this length 20 here. Then this is a radius of a sector, so therefore we also have 20 here. Therefore, we can calculate this length, 15. We can use the arc length formula, r theta, remembering to use theta in radians, to calculate an arc length here. 5 pi by 6 multiplied by 20, 52.36. We can also calculate the arc length up here, which will be 10 multiplied by pi over 6, 5.236. We can now add up all of the lengths, and this will give us the perimeter. We can also calculate the areas. For example, we have 350 here. We can also calculate 200, and using the half r squared theta, we can fill in the sector areas here. So therefore, the perimeter of the shape, rounded to 3 significant figures, is 148. The area is 1,100. Now complete exercise 1.2 on page 260.